Myself, Srinivas, I'm working as a faculty in the Department of Mechanical Engineering at Sri College of Engineering and Technology. So the last couple of lectures, we have been discussing about RLM, GRU, and LSTM. Among all these architectures, and our LSTM will perform better in case of sequential modeling. To predict the next word, I'm going to use LSTM, and these are the libraries to be imported from in Python. Okay. So this is NumPy for remedial calculations, and from Keras we have to import the tokenizers. So the tokenization is a word that we use in NLP, in natural language processing. So basically what it does is it tries to convert it to small tokens. So suppose if you have a sentence, okay, so if you have a sentence, it converts into small words, or I can say token, or I can say small units. So this is called tokens, and this has been imported from Keras. This is called tokenizers. This two category is basically for the one or two presentation. And since we work on a sequential one and neural network, and we have to import the sequential from Keras. And we have to import embedding LSTM lens from the Keras, and embedding is basically it tries to convert the words into vectors, and LSTM basically that is a model that we are going to use to predict the next word, and this dense we try to convert and try to predict the next word. And each sentence will not have the same length, and to have that we are going to use this paired sequences. Okay, so padding will be used before training, and these are the libraries to be imported in Python. So this is the data. So I have 20 sequential, 20 sequences. Okay, I have 20 sequences. So each one is basically I'm not going to read all these things. I'm going to read a few things. And Anna University is a premier technical university. Anna University is located in Tamil Nadu, and Anna University promotes innovation and research. And students learn machine learning and deep learning again. And students learn programming using Python and data science. And so the technology in education helps students build innovative solutions. So these are the data that we are going to fit. So I have, because I said I have the 20 sequences. I'm not going to display all these things, but I have displayed most of the things what I have used in this lecture. So this is object. This is a tokenizers, and already it will be imported from the data. Okay. So what it does is basically tokenizer that fit on text data is basically we're trying to have this vocabulary, and each word will have some indexes, and the total number of words is basically a unique word. Okay, so this is has to be a length of whatever this we have used plus one. Suppose if I have 100 words, okay, suppose if I have 100 words, it starts from 0 to 99. Okay, so here we have input sequences will be stored over here. And the most important thing is n-gram sequences. Here we are going to use this 2, that is in bigram. Suppose if I have, if I say I love deep learning, okay. So I love deep learning. So I love is basically my input. The target one is going to be deep. Target one is going to be deep. Suppose, as I said, this is I. In this loop, I represents 2, that is going to be 1 comma 2, something like that. Suppose if I put I is equal to 3, so that is going to be 1 comma 2 comma 3. Suppose if I put I is equal to 4, it is going to be 1 comma 2 comma 3 comma 4. So this is the way it works, and each sequence will have a different length, and in order to have that, we have to pad those things. For example, I can say, so 1 comma 2 comma 0, 1 comma 2 comma 3. Suppose if I have 4, it is going to be another 0. So this is a, we have to make it uniform. You should have uniform length, and we will have this kind of we'll use this kind of padding. Okay. So now we have to separate the last word from the sequence. So that's why I put -1 over here. And suppose if I say I love deep learning, the learning will be so this is going to be my x. This is going to be my x, and this is going to be my y. Okay. So we are similarly, whatever the things we do, it has to be one out representations. Okay. So already we discussed one out representation in the couple of lectures back. So whatever we have done, it has to be before training. It has to be one out representation. So we are using this LSTM model. Okay, this is a model that we are going to use. Since we work on neural network, we use a sequential one. This is for the case of trust. We add embedding a different number of words. That is going to be unique words. So this is going to be a 50 for each word. Will have different 50 dimension, I can see. So 50 dimensions will have, I can see. Then each will have 50 values. Okay, this each will have 50 values. The LSTM will have 150 neurons, 150 neurons. So each neuron will look at different patterns, different sequence, I can say. Each neurons will look at different sequence. Okay. So this is the way it works, and we try to convert this into numbers, and we use this for activation. Since it is a multi-class problem, we use the softmax functions, and it will give you a probability. And for the last categorical cross entropy will be used to measure that. And we use add-on optimizer, and we are interested in accuracy. And to train that, and we use 300 epochs. So this is the architecture that we use in our case. Okay. And the most important thing is temperature, and what is this? It try to adjust the probability. So basically, if you have different classes, you will have different probabilities. This temperature scaling will try to adjust the probabilities, and then we have to remove the unknown. Suppose based on the probability score, for example, I can say one is 0.4 and one is 0.3 and another one is 0.001. So we have to remove this probability score. So we have to use this top case apply. Okay. So the temperature values where it is less than 1, it is balanced. Okay. And it will try to adjust the probability in this case. So we remove this unwanted, whenever we have a low scoring, the top K will be selected over here. And if there is a repeated words, it will be removed. So what is that we have given here? We have given this the word Anna University. Okay, this is a seed text I have given. So I'm interested to find the next 5 words. That's why it is given 5 here. As I said, just the probability we use temperature. It should be, if it is less than 1, it is fine now. And we are interested to look at top 5 probabilities. Okay, top 5 keys, top K sampling. So I have given 5 over here. Okay. So the word I have given is Anna University based on the data that we have. And I'm interested to look at what is going to be for the case, what is going to be the next 5 words. So the predicted sentence is basically here, and Anna University is located in Tamil Nadu. Okay. So the moment you give different, if you run repeatedly, then you'll have different sequences being produced. Okay. So that is the way it works in case of LSTM. So basically what we are trying to do here, what is the flow of this work is, basically we have a text and is getting converted into tokenization. So we are interested to small words, okay, then vocabulary, and we do this padding, okay. So in order to have a similar length, and we do this LSTM, this it will go to the train the model, okay, and we do temperature scaling, and top case sampling. And so once it is done, it does have, because we have all the words are indexed, and we have to convert that into index to word now. Okay. So once it is done, and it has to be the previous slide, it has been described here. Um, Index to word. Then we have to append the next word, and finally we will be able to see the final output. So this is a workflow we see in LSTM. So I'll summarize once again now. We have sequencer data, then those sequences has to be converted into small units, that is called token. Tokenization has been used. Okay. So each word will be indexed, and each word, once it is indexed in numbers and creates that sequences, and once it creates, and we have that paddings, because one, two, three, and if you have different sentences, you will have different, we have to make it uniform. That for that we have used padding, and once it is done, padding is done, we could we go for training. Okay, so that has to be in terms of one or two presentations, and why we have to go for the training. For the training, we use the LSTM, and before the training, we have to split the data X and Y. Okay, that's we do. And once we have this 150 neurons here, and it will try to see different sequences here. Then once it is done, we have to convert in order to have better accuracy, and we do this top case sampling and temperature scaling. And temperature scaling will try to have better probability. It will try to adjust the probability. Top case sampling will try to pick the top few probability scores. And so once it is done, then that whatever we index, because the computer will see only this in numbers. Okay, so the indexing will be converted to words. Okay, indexing will be converted to words, and then again the words is going to be appended, and finally when we ask what is the next word, it is going to come, and it will be predicted as output. Okay, so that is the way it works in word prediction when we use LSTM architecture. Thank you.